You hear all the time about the insane amount of energy that cryptocurrency mining uses. It's a huge problem. But what if all that computational power, instead of just burning electricity, could be used for something, well, useful? What if a blockchain could be more than just a ledger for money? What if it could be a global, decentralized physics lab? Let's get into it.
Okay, so this slide just lays it out perfectly. On one side, you've got the old way, traditional proof of work. It's basically a brute force guessing game, solving meaningless puzzles and just wasting a ton of energy. But on the other side, you've got this new idea, quantum proof of work. Here, miners are actually running useful physics simulations, so the effort goes from wasted energy to useful computation. It's not just a tweak, it's a completely different philosophy for what a blockchain can do.
So here's our plan for today's explainer. First, we'll look at that big shift from waste to worth. Then, we'll dig into how quantum proof of work actually works under the hood. After that, we'll talk about what it means to have a ledger of physics and what you can do with it. And finally, we'll get real about the promise and, the problems facing this tech right now. All right, section 1. This is all about the core problem Qubitcoin is trying to solve. How do you stop throwing all that computational power away and turn it into something valuable? And the big idea here is actually pretty simple, but it's genius. You just replace the pointless cryptographic puzzles with verifiable quantum simulations. Suddenly, the proof of work isn't about proving you wasted electricity. It's about proving you contributed to a real computation, that the work itself has actual intrinsic value. Okay, so let's move on to section 2 and see how this actually works. I mean, how on earth do you build a secure blockchain consensus around quantum physics? This slide breaks the whole thing down. So a miner takes some data from the block they want to add and uses it as the input for a small quantum simulation. Think of it like a tiny digital physics experiment. The result of that simulation then gets baked into the block itself. And this is where it gets really clever. Other computers on the network, the validators, they don't just trust the miner. They run the exact same simulation with the exact same inputs. If and only if their results match the miner's result perfectly, then the block gets approved. It's a system built on scientific reproducibility, not just trust. Now, the secret sauce that makes all of this work is something called deterministic reproducibility. It's a bit of a mouthful, but the idea is simple. These little quantum simulations aren't random. If you put the same inputs in, you will get the exact same output every single time. And here's the best part. You don't even need an actual quantum computer to do it. The GPUs that miners already have are more than powerful enough to run these specific simulations, which makes this whole idea of decentralized verification possible today. And this right here, this is the whole game changer. With something like Bitcoin, a block is valid because a miner got lucky and guessed a random number. With Qubitcoin, a block is valid because the miner correctly simulated the laws of physics. If the physics is wrong, the network knows, and the block is rejected. The proof is literally in the physics. So, if the work is physics and the verification is physics, what does that turn the blockchain itself into? Let's jump into section 3 because the implications here are pretty profound. What happens is the entire network becomes this massive distributed physics engine. You can think of the miners as researchers conducting experiments, and all the validators are like their peers, independently double-checking and verifying the results. It's pretty much the scientific method, just built into the code of a blockchain. And the whole system is built on these 4 key pillars. 1, the simulations have to follow the actual laws of physics. 2, everything, the inputs, the outputs, is stored forever on the blockchain. 3, the checking is done by thousands of independent computers all over the world. And 4, miners get paid to do honest physics. It's a really robust setup. This quote just nails it. The blockchain isn't just a record of who paid whom anymore. It becomes a permanent, unchangeable archive of scientific computations that anyone can check any time. Okay, this is all fascinating in theory, right? But what could you actually do with a blockchain that verifies physics? Let's get into the practical applications in section 4. First up, think about what this does for research. It could create a public, global lab for testing new quantum algorithms. A researcher anywhere in the world could submit their idea to the network and have it validated by thousands of computers, all without needing to own a multi-million-dollar quantum computer themselves. It really democratizes access. Then there's auditing. This is huge. Think about all the critical industries that rely on complex computer models. Climate science, new materials, energy grids. A lot of those models are black boxes.
Qubitcoin could be a way to publicly verify that the computations are being done correctly, adding a layer of trust without forcing companies to reveal their secret sauce.
And this one is super interesting for the future of quantum computing itself. The network could act as a neutral, impartial referee. When a company claims their new quantum chip can do X, Y, and Z, you could use the network to run simulations that verify those claims. No more taking a company's word for it.
And now for something that sounds straight out of science fiction, connecting smart contracts to the real world. Imagine a crop insurance contract that automatically pays out if a verified weather simulation on the blockchain shows a drought, or a prize for a scientific breakthrough that's automatically released when the network verifies a simulation that proves it. It's a way to build a verifiable bridge between the digital and physical worlds.
Now, as cool as all this is, we've got to be realistic. This isn't science fiction, but it is still very early days. So for our last section, let's take a clear-eyed look at both the incredible promise and the very real limitations that exist today. So here's the balanced view. The promise is huge, a system that's open, auditable, and tamper-resistant. But the limits, right now, are just as real. For one, the size of the quantum simulations you can run is still pretty small. Also, and this is a key point, the network verifies that the computation was done correctly, not that the underlying scientific model actually reflects reality. And of course, storing all this data on-chain could get really bloated. These are big hurdles to overcome for sure. So what's the big takeaway here? It's that with Qubitcoin, the work in proof of work finally means something. The network is proving that miners correctly reproduced a real physical process, not just that they burned a bunch of energy guessing a random number. This quote really sums up the whole vision. We live in a world where so much science happens behind closed doors, on centralized computers. This offers a new model entirely, a way to do physics that can be checked, reproduced, and trusted by anyone, anywhere. And that leaves us with one last really big question. It's a bold thought, and we are a long, long way from this being a reality, but when you look at how a system like this is designed, you really have to wonder, could the future of scientific truth, or at least our permanent record of it, actually be written on a blockchain?